In this video, we're going to have a look at how we work out ordered selections. Now, ordered selections are also known as permutations, and we're going to look at how we can find out how many possibilities there are in those ordered selections. So, an ordered selection also, as I said, is known as a permutation. It occurs when a selection from a group of events is made and the order is important. So we'll look at some examples of what is important. So students running in a race, the order that they finish is important. A group of people wishing to be captain or vice captain. So we usually select the captain first, then vice captain. So the order again is important. Tickets in a raffle. So we usually have first prize, second prize, third prize. So the order that they're drawn out again is important. Or another one is if we've got, say, 5 cards numbered 1 to 5, and we select 2, and to make a 2-digit number, the order that they occur is important. So what we'll do now is have a look at some examples on how to do this. So the first example, we're going to consider 8 students in a race. Let's find out how many different possible ways they can finish. Now in this, we're going to assume that there are no dead heats and that everyone has the same possibility in winning and becoming a place. So the number of arrangements. You'll notice that I've got placed along here 8 positions. So they're the positions that they can finish. So in this first position, we have 8 different possibilities that someone can become first. So we're going to place that 8 in there. Now once someone has come first, to fill second spot, there are only 7 more runners to fill in there. So again, person who come first can't come second as well. So we've got first, then second. Now that we've got our first and second positions filled, we have 6 more runners that can fill in the third position. And then we have 5 more runners that can fill in fourth, 4 that can finish fifth, 3 that can come in and finish or fill in the 6th position, 2 for the 7th position, and then 1 for the final position. Now what do we do with all of those? We then multiply those together, and that will tell us the number of different possibilities that those 8 runners can come in. So we end up with 40,320 different ways that those students can finish for those 8 full positions. What we're also going to consider then is just how many different possible ways they can just finish first, second or third. So unfortunately I'm not worried about who comes fourth, fifth, etc. We just want first, second and third. So again, let's work out the number of arrangements, and I'm only considering first, second and third. So I'm not worried about the rest. So in this first position, I have 8 different runners that can fill that position. So I can put my 8 in there. Now that I've filled my first position, I can have 7 more fill in my second position. And then I've got 6 more to fill in my third position. And as I said before, I'm not worried about the other positions, just first, second and third. And we multiply those together and we end up with our 336 different possibilities for the first, second and third out of those 8 runners. Alright, so I also mentioned before that these are also called permutations. Now many calculators have a button to help us, and it looks a bit like NPR. So let's have a look at how we then go and work out that using that NPR button, P for permutation. So NPR, now the number of students we have to choose from in this race, there's 8, so that goes in where our N is. So we have 8 PR, but the number of positions we want to fill, well, we weren't worried about any in particular, we wanted all of them, so we have 8P8. And we're going to have a look at how we do that on our calculator. So let's call up our calculator, and we'll notice for our Casio FX82AU plus 2, above the times button we've got our NPR. Now for different calculators they'll have them in different positions. So for this particular one we had 8 people in the race. Because it's in yellow, I press Shift, then NPR, gets my P up there on the screen, and I had 8 positions to fill, and press equals, and we get our 40,320 possibilities. Alright, well, let's have a look at the other type. When we've finished first, second or third, so our NPR again, we had 8 runners, but this time we're only going to fill 3 positions, first, second and third. So let's clear that off our screen and do that on our calculator. So we want 8 students, shift times to get our P for permutation, and then we're only filling 3 positions, press equals, and we also get our 336. So that's how we use our calculator, and we can always set it up like I have here to work out the same result anyway. So let's have a look at another example involved with the race. We're going to determine the probability that Anna comes first and Beatrice comes second. So Anna and Beatrice are 2 students in the 8. So remember, probability, that's what we like to work with, the chance of something happening. So the probability that Anna first, Beatrice second. Well, we've got 8 positions, remember. So Anna first, there's only one possibility for Anna first, one possibility for Beatrice second, and then we've got 6 students left that could come third, 5 for fourth, etc. And remember that there are 40,320 different possibilities that we worked out before. And just like we should always do with fractions, we should simplify. So we end up finding out that they've got a 1 in 56 chance of Anna coming first and Beatrice second. Alright, so another example. 6 people have nominated for captain and vice captain. So yes, the order, captain first, then vice captain, is different from vice captain than captain. Okay, so the order that they draw out is important. So in how many ways can these positions be filled? Well, let's work that out. Number of ways. Remember, there are 2 positions, captain and vice captain. We've got 6 students who can become captain. Once we've chosen a captain, we've only got 5 people left to fill in the vice captaincy. And again, we multiply those together, so we have 30 different possibilities. Again, we could use our NPR, our permutations. So there are 6 candidates. There are 2 positions to fill. So 6P2, if we do that on our calculator, we can call that up, clear the previous one. So 6P2, and we get our 30 different possibilities there. Alright, so let's look at tickets in a raffle. We're going to say that there's 100 tickets purchased for a raffle, and we want to know how many different ways can first, second and third prizes be drawn. So let's work out that. Remember, there are 3 positions, first, second and third prize. Obviously the order is important, because if you're drawn out second, you don't get first prize. So there are 100 ways we can choose, or possibilities for first place or first prize. There's only 99 left for second prize and 98 left for third prize, and again we multiply those together and we've got 970,200 different possibilities there. Or again, we can do our NPR, so our permutation, 100 possibilities, and the order is important, and there are 3 positions that we're going to fill there. So do that on the calculator, we get the same result. And the 4th example here, we've got 5 cards and they're numbered 1 to 5. We're going to select 2 cards to form a 2-digit number, and we're not going to replace the card. So that's important, because otherwise we get repetition like 11, 22, 33, etc. So let's calculate the number of 2-digit numbers that can be made. So the number of possibilities, we've got 2 positions. First position, we've got 5 different ways that can be filled. And then second position, we've only got 4 cards left. So we've got 4 different ways that we can choose that. And that gives us 20 different possibilities. Now again, if we use our permutation, then we get 5 possibilities to fill 2 positions. Now something I failed to remember or to mention before was I was told by a colleague who's been teaching for a number of years that we can emphasize this P so that we know which one we're doing, because later on we'll have a look at combinations and people get them mixed up. So if the order is importance, and we're emphasizing the P for importance, then we can remember that if the order is important, then we can use this permutation on our calculator. So we can use the NPR on our calculator because the order is important. We've got an NCR here as well, and that's for later on when we've got combinations where we couldn't care less about the order. Okay, so let's do another example with these two-digit numbers. How many of these would be greater than 30? That means we have to be two-digit numbers 31, 32, 33, etc. Well, let's look at our number of possibilities. For our first position, we either want to put in a 3 or a 4 or a 5 in there. I can't put a 1 or a 2 because that wouldn't be greater than 30. So we want a 3, a 4 or a 5, which means I have 3 different possibilities to fit in there. Once I've chosen one of those 3, I've still got 4 cards remaining, and I don't care whether they're a 1 or a 2 or a 5. So I've then got 4 possibilities left, multiply those together, and I have 12 different possibilities for a two-digit number being greater than 30 out of those 5 card possibilities. Okay? So I hope you've enjoyed that, but what you really need to do now is practice, and then practice, and practice again, because the more you do that, the better you're going to get at this. So I hope you've enjoyed this video and have found it useful.